What's up, guys? It's your boy. We're back with another question for the exam review. It's a test. It's not an exam. I shouldn't say that. But anyway, this question, number 5, we have Mr. Duvernay. By the way, this is an EN question, meaning it's on the easy and normal versions of the exam. One like this does not appear on the hard version. Mr. Duvernay climbs into his honeybee-shaped airship and raises anchor, preparing to set sail. He starts from rest and accelerates at a rate of 6 meters per second squared. How quickly is he moving when he takes off a 31-meter-long runway? Okay. So first things first, here's the runway, here's Duve's plane. Our initial point is here, our final point is here. So he's going to get in this plane, he's going to accelerate, going to gun the engine, going to make it to this, point here, and then we're going to take off, right? So our initial point is 0. We're going to call that 0. That's xi. We are going to be zooming this way. We start from rest. When we start from rest, that means that we have an initial velocity of 0. And we accelerate at a rate of 6 meters per second squared. So the acceleration is 6. It's going this way. And we want to know how long it will take him to get across a 31-meter long runway. So this distance is 31 meters. Let's go ahead and gather our variables up. On the equation sheet, we can see that our variables that we have are xi, xf, initial and final position, vi and vf, initial and final velocity, acceleration and time, or a and t for acceleration and time, rather. So we started, let's take a look at what we got. So xi we can always call 0, that's fine. Xf is the final position, the length of the runway, in other words, right? So in this case, it's going to be 31 meters. Our initial velocity, since we're starting from rest, like I said earlier, our initial velocity is going to be 0. We want to know how quickly he's moving when he takes off the 31-meter long runway. So how quickly he's moving when he takes off here is actually our final velocity. We want to know what his takeoff speed is. Then our acceleration is 6 meters per second squared, which the problem tells us, and time we are not given. So we're going to use number 5, the equation that does not involve time. So that's vf squared equals vi squared plus 2 times a times xf minus xi. This is the equation that appears on your equation sheet. We can go ahead and put our numbers in here. Pardon me. We can go ahead and put our numbers in here and try to solve this. So vf is vf. Leave that as vf. Vi is 0 squared plus 2 times a. Acceleration is 6. Xf is 31. Xi is 0. Solve this for vf. Okay, so 0 squared is 0. That's going to drop out. We don't care about that shit. Oh, that stuff, excuse me. Vf squared equals 2 times 6 times 31 minus 0, which is just 31. So here we can say 2 times 6 times 31 for this part here. So 2 times 6 times 31 gives us 372. So now Vf squared is 372. We can take the square root of both of these sides, and we get Vf equals 19.3 meters per second. So that's how we solve a problem like this. This is similar to what you'll see on the easy and normal versions of the exam. Hopefully you're not finding these too hard. I will see you guys for the next solution.